Welcome dear students to this session. Dear students, today we are going to discuss from class 9 mathematics book chapter 6 lines and angles part 4. Dear students, in the previous class we have learned about some theorems on parallel lines and transversal. One of them is if a transversal intersect two parallel lines, then each pair of alternate interior angles is equal. And its converse is if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. And third one is if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. And its converse is if a transversal intersects two lines such that on the same side of the transversal is supplementary, then the two lines are parallel. So this was all we discussed earlier, and today we are going to learn about parallel lines and a transversal, and here lines parallel to the same line and related problems on parallel lines. So let's have a look at the picture that a line is there. If some other lines are parallel to this, then what happens? If two lines are parallel to the same line, will they be parallel to each other? Let's draw two lines, M which is parallel to L and another line N which is also parallel to L. Then will M and N be parallel? So what is the relation? As we discussed now, the relation between the lines and M and N is stated in the following theorem. Then what this theorem states? Lines which are parallel to the same line are parallel to each other. Let's look at this figure. Line M is parallel to line L and line N is parallel to line L. Now what to prove? We have to prove line M is parallel to line N. Now we have to construct something to prove this. What is the construction? Draw a line T transversal for the lines L, M and N and name their respective corresponding angles as 1, 2 and 3. Then after naming these corresponding angles, now let's see how to prove it. It is given that line M is parallel to line L and T is the transversal. Then what are the corresponding angles? So angle 1 and angle 2 are the corresponding angles. So they are equal. Now let's consider another pair, that is N with L. Then T is the transversal. If line N is parallel to line L and T is transversal, then what are the corresponding angles? The corresponding angles are 1 and 3. So these two are also equal by corresponding angle axiom. So we have now two equations, that is equation 1 shows that angle 1 is equal to angle 2 and the equation 2 shows that angle 1 is equal to angle 3. So from these two equations we conclude that angle 2 is equal to angle 3. Now look at the figure. What are the angles 2 and 3? Angle 2 and 3 are corresponding angles of the transversal T by M and N. So, as these two are corresponding angles and they are equal, so line M is parallel to line L. This is the converse of the corresponding angle axiom. Now, we completed this theorem. Now, let us have some problems to in which we will apply these theorems. See, here the question is, in the given figure, if AB is parallel to CD and CD is parallel to EF, Y is to Z is equal to 3:7, find X. So, from this statement, we see that AB is parallel to CD and EF is also parallel to CD. So, AB is also parallel to EF by the theorem we discussed just. Now, so let us have a look at this board. Here it is AB, CD and EF, where P, Q, R are the point of intersection by the angle APQ is named as X, angle PQC is named as Y, and angle QRF is named as Z. Now, you see angle as AB is parallel to CD, we have PQ or PJ are transversal, we can say that angle APQ plus angle PQC equal to 180 degree because co-interior angles. Co-interior angles. These two are co-interior angles. This shows that X plus Y is equal to 180 degree. As AB is parallel to CD and CD is parallel to EF, this implies AB is parallel to EF. AB is parallel to EF and PQ is the transversal. This implies angle APQ is equal to QRF. See, what is APK? APK is X and QRF is Z. You see, X plus Y is 180 degree, X is equal to Z. So, from equation 1 and equation 2, what do we get? From equation 1 and 2, we get that Z plus Y is equal to 180 degree. Because X equal to Z, in place of X we can write Z. So, Z plus Y is 180 degree. And also Y is to Z given to be 3:7. Then what is Z? Z is equal to 7. Corresponding value of Z is 7 by sum of the ratios, that is 3 plus 7 into what is the sum of y plus z, that is 180 degree, that gives 7 by 10 into 180 degree, 7 by 10 into 180 degree, that gives 7 into 18, that gives 126. So value of z is 126. Earlier we proved that x is equal to z, hence x is equal to 126 degree. So this is our solution. So by applying the last theorem and alternate angle theorem, we could solve it. Here a figure is given and PQ is parallel to ST. Angle PQR is 110 degree and angle RST is equal to 130 degree. What is the measure of angle QRS? Now you see PQ, the figure is like this. Here it is PQ and ST and this is R. Given PQ is parallel to ST, angle PQR is 110 degree and angle RST is equal to 130 degree. To find the value of this QRS, let's have a construction. Draw a line through R which is parallel to PQ. So draw a line through R parallel to PQ. If PQ is parallel to ST and PQ is parallel to, say, let this name be AB. Draw a line AB, say. Draw a line AB through R parallel to PQ. PQ is parallel to ST and PQ is parallel to AB. So this shows that ST is also parallel to AB. Now if ST is parallel to AB and let SR is the transversal, SR is the transversal. So SR is transversal. From this we get angle TSR plus angle SRB equal to 180 degree as co-interior angle. These two are co-interior angles. Out of this, we have given TSR to be 130 degree. So 130 degree plus SRB angle is equal to 180 degree. That shows angle SRB is equal to 180 minus 130, that is 50 degree. Similarly, as SRB is now, this is 50 degree. Now come to the parallel lines PQ and AB. If PQ is parallel to AB and QR is transversal, then what happens? Similarly, angle PQR plus angle QRA is equal to 180 degree co-interior, which gives angle PQR is 110 degree. So 110 degree plus QRA angle is equal to 180 degree. From this we get that from this, let's wipe it. This shows angle QRA is equal to 180 minus 110 degree, that is 70 degree. So this angle become QRA becomes 70 degree. So we have in this figure we have here 70 degree and this is 50 degree, where Q is somewhere here and S is somewhere here. Now see, at R, as this is ARB is a straight angle, so sum of these three angles will be 180 degree. Hence, angle QRA plus angle SRB plus angle QRS is equal to 180 degree. Now put the values of QRA and SRB. Your QRA is equal to 70 degree and SRB is 50 degree plus QRS is equal to 180 degree. Now this is 120 degree plus angle QRS is equal to 180 degree. This shows angle QRS is equal to 180 degree minus 120 degree, that is 60 degree. So this was our question, find angle QRS, and we found that the value of angle QRS is 60 degree. So just by applying the theorems of the parallel lines we can solve it. Let's have a look to another question. Here the question is like this: AB is parallel to CD in this figure and angle APQ is equal to 50 degree and angle PRD is equal to 127 degree. Find the value of X and Y. Now see, in this figure AB are two parallel lines. A line like this, that is PQ, and another line is like this PR. Angle APQ is given 50 degree and angle PRD is given 127 degree. If this value is X, that is PQR is X and QPR is Y, find the value of X and Y. Now how to solve this? You see, AB is parallel to CD and PQ is the transversal. This implies angle APQ is equal to angle PQR. Now put the values of APQ and PQR. What is APQ? APQ is 50 degree, and what is PQR? PQR is X. That means here value of X is equal to 50 degree. Now PRD is 127 degree. Again, considering AB is parallel to CD and PR as transversal. PR is transversal. What did get? We get that angle APR is equal to angle APR is equal to angle PRD. See, angle APR is made from two adjacent angles. What is that? APQ, QPR. So, in place of APR, we can write angle APQ plus angle QPR is equal to angle PRD. Now put the values of these angles. APQ is 50 degree plus QPR is y degree and PRD is 127 degree. From this we get y is equal to 127 degree minus 50 degree, that is 77 degree. So we got X equal to 50 degree and Y is equal to 77 degree. So this is also application of those theorems. Now see another question. The question is like this. In the given figure, PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B. The reflected ray moves along the path BC. You see, the reflected ray moves along path BC, and again it strikes at RS, and it is again reflect back in CD, along CD. So we have to prove that AB and CD are parallel. So to solve this, we have to recall the law of reflection. In that case, we have a figure like this. Let's draw two normals or perpendiculars BM and CN at PQ and RS respectively. And in such case, angle ABM is the angle of incidence and MBC is the angle of reflection, and these two are equal. Similarly, BCN is angle of incidence and NCD is the angle of reflection. So angle 3, angle 4 are also equal. So using this law, we can solve this. As you see in this figure, your angle 1 and angle 2 are equal. Angle 1 is equal to angle 2 by laws of reflection. Similarly, angle 3 is equal to angle 4 again by laws of reflection. Now you see PQ is parallel to RS and BM is perpendicular to PQ, This implies BM is also perpendicular to RS. If we extend it, then it will also perpendicular to RS. And also we have given CN is perpendicular to RS. This implies, see, BM is perpendicular to RS, CN is perpendicular to RS. This shows that BM is parallel to CN. Now taking BM parallel to CN, and what is the transversal? Look at the figure. The transversal is BC. In the figure, it is the transversal of BM and CN is BC. If these are the, if BC is the transversal, this shows that angle 2 is equal to angle 3. This is alternate interior angle. Now as 1 and 2 are equal, 3 and 4 are equal, and here 2 and 3 are equal, that means all these angles are equal. If we consider angle A, B, C, this is equal to angle C. A, B, C constitute of angle 1 and 2. So angle 1 plus angle 2. These two are equal, and 2 is equal to 3 and 4. See, 1 equal to 2, 3 equal to 4, and 2 is equal to 3. So 1, 2, 3, 4 all are equal. From this we can write that 3 plus 4 are also, in place of 1 plus 2, we can also write 3 plus 4. And this 3 plus 4 gives angle BCD. Now if we consider that ABC and BCD, if we look at the picture, ABC and BCD, these are alternate interior angles if BC is the transversal of line AB and CD. But these are alternate interior angles formed by transversal, which is the transversal? Transversal BC with AB and CD. So this shows, as the alternate angles are equal, so the lines are parallel. So this shows that AB is parallel to CD. This is converse of the alternate interior angle theorem. So dear students, today we discuss about the parallel lines and its application, the theorem of parallel lines and their applications. By using those theorem, we could be able to solve some problems from the parallel line based questions. So dear students, this is time now. Have a good day. Thank you.